Development of circular buildings involves many challenges on a way, starting from social acceptance and perception of quality by users, to meeting technical challenges of deconstruction and financial feasibility of reuse and recycling operations. UIA Super Circular Estate project in Kerkrade has demonstrated number of reuse strategies and monitored their social, environmental and economic impacts. This UIA Experts report zooms into the monitoring process that has been conducted by ZUYD University of Applied Science. Michiel Ritzen from ZUYD University highlights monitoring process and its results.
So we measured the social acceptance of the circular solutions in a threefold way. First, we used qualitative and quantitative surveys with neighbors. We sent out these surveys, how they would reflect actually on reusing and recycling materials. So to give you an example, for instance, do people accept a reused and recycled kitchen or toilet? Do they sit on it? The second thing is that we had in-depth workshops with professionals. And the first methodology we applied was informal meetings with inhabitants and neighbors. We measured the material circularity based on the standard LCA methodology that's actually used worldwide and in the European Union. There are 16 indicators, but we thought, what's the use of applying these 16 indicators? So we had some in-depth discussions and workshops with the project partners. And we asked them, what's for you important to become more circular? And they said, we look at 3 indicators. Embodied energy, so what is the energy needed to fulfill this process? The CO2 emissions related to this process. And thirdly, the shadow costs. So what are the additional costs of these kind of solutions? From the monitoring process, considering the social acceptance of circularity, we saw that the circular solutions were either accepted when they were really visible circular. So for instance, when you would have the concrete and it would be cut with a diamond saw and you could see the small pebbles and the steel reinforcement, that was directly accepted. It was as well accepted when people didn't see that it was circular, but what was not accepted was when it was a bit of in between. So that's considering the social acceptance of circularity. From a material point of view, we saw that actually not the biggest chunks were the best solution. So we thought the biggest chunk is a complete apartment, we hoist it out. That was not the lowest environmental impact solution. The lowest environmental impact solution was with small slices, like 1.2 by 2.4 meters, and hoist those out, because then you have a lot less materials necessary and installations necessary. Points that are different than in a traditional construction project is, first of all, the activation of the neighbors. In many cases, projects are only built and then sent to the neighbors, to the inhabitants, and that was here a different case. The second thing, of course, is the massive ambition, the very high ambition of reuse and recycling of building components. And this is, in that sense, a groundbreaking project in which I'm not aware of these kind of chunks being hoisted out and being reused for new dwellings like these. And the third point is that besides all this social circularity of neighborhood activation and inhabitant activation and material reuse, the whole neighborhood has a complete circular water system. So all the dwellings, they have vacuum toilets, and all the grey and black water will be filtered and cleaned on site. So in the superlocal project, we've reached an amount of above 90% of reused and recycled material. So that is very high, I would say. But we looked as well at the environmental impact indicators. So for instance, embodied energy. And then you see that it is a little bit lower, so we're about 70% embodied energy savings. There are two real big barriers at the moment for these kind of projects. The first one is legislation. So we succeeded in this project thanks to the municipality of Kerkrade that was really willing to think with the whole project team and find the solutions. So for instance, officially these houses are not new houses. This is a retrofit of the existing apartment only on another place, because they would not be a fit to the current building regulations in the Netherlands. So you need other legislation. And the second thing is the business case. These kind of solutions are at this moment really too expensive to be applied in the market, throughout the market. So one of the solutions in that field is a better CO2 taxing. Price, environmental impacts. From this project we learned two things in possible applications in other building projects. The first one is really low-scale, low-hanging fruit solutions, like reapplying the kitchen and reapplying, for instance, the wash tub or the toilet sink. You have a very small amount of actual impact on the environment with that solution. It's only a very small part, but you create a lot of activation of inhabitants, and as well you create a situation that they accept the solutions. So that's from one side a very important point to work on, and on the other hand try to reuse all these elements. Look at what's possible, what's available from the demolition stock, and reuse that in new buildings. The most important key recommendation that we learned from this project is: do not think about how you construct a building. Think about how you deconstruct a building. Think about multiple cycle circular solutions. So think about an apartment building not from that first phase use as an apartment, but think about what can be done with these materials in following phases. So for instance, do not make an apartment building completely from concrete without being able to take out certain parts and reuse those parts. That is really the main takeaway from this project. And the second takeaway, and that's more for policy and legislation, we need another taxing system. Do not put taxes on labor. For instance, this was a very labor-intensive project, but put taxes on environmental impact like CO2. The main policy takeaway that we learned here is that if you deconstruct instead of demolish, you need a lot more laboring time, but you have a lot lower environmental impact. So if you lower taxes on labor and create higher taxes on environmental impact, that's the way to go forward with circularity in the built environment.
Existing buildings are not made with material recovery and reuse in mind. The reason why construction industry has high negative impact on the environment through tons of waste and CO2 emissions. Lessons learned from the UIA SCE project in Kerkrade indicate that besides design and technical innovation, a new regulatory mechanisms need to be put in place in order to enable reversibility of negative impacts of construction on the environment. This expert's report elaborated lessons learned from the monitoring of SCE project, as well as takeaways for future circular buildings inspired by UIA SCE project.